Hi, good afternoon, everybody. How are you guys going? How are you feeling? Sorry for logging on so late. Was having a bit of an issue with Zoom and the update. But we're just gonna wait about 5 more minutes and then we're gonna jump into it. So make sure you have everything that you need. Just gonna take this opportunity to send you guys a reminder about the multiple choice questions. Hi, Myrtle. That's good. You're feeling awesome. Today was my first day back out to school. So I had a day. A little nervous about school reopening and seeing students face to face. I'm excited about that, but students always all over me. So I'm a little nervous about being back in school and, social distancing and all that stuff. But hopefully, it should be perfectly fine. So we're going to start in a few. So I'm just going to share my screen in the meantime. I've been having some internet issues as well, guys. So if anything, let me know. Just keep in check with me about hearing and seeing. So we're gonna begin shortly. Today we're gonna be jumping into algebra, which is mostly the topic area that most people struggle with. But I'm gonna try my best to make sure we have a strong foundation, because I'm gonna tell y'all the very honest truth. If you are weak in algebra, all of the other advanced topic is going to be very, very challenging. So start mentally preparing yourself to, overcome that challenge, because it's going to give you an advantage in every other topic area after. Hi, guys. All right, guys. So let us get straight into today's lesson. I just had to give myself a little energy boost. I'm having some internet trouble. I think I am as well.
Excuse me.
Hi. Somebody's talking. Okay, so thank you for letting me know. Okay, guys, we're gonna jump straight into it. Algebra. So before we get into algebra, I need y'all to just mentally prepare yourself for some information and understanding what algebra is all about. Is not just about the whole issue about using letters in maths. Yes, that's one aspect. But one, algebra, you actually use algebra every day. A lot of people just be like, when am I gonna learn to? When am I gonna use algebra in real life? You use algebra. If it's one area you use every day,
I mean, crash that, you know?
So an example would be like, for example, if I buy a pen for $2 and somebody asks, let me just mute because I'm hearing somebody talking over the mic. So I'm just gonna mute everyone. All right, so as I was saying, so if you go and you buy a pen for $2 and somebody comes in and asks, well, how much would 5 pence cost? That is algebra, because in this case, you are required to find an unknown quantity using the quantities that you were given. And so we're going to begin today's class discussing the whole idea of known and unknown quantities and how we can represent those quantities using letters. So we're going to scroll through, we're going to skip through our first set of slides because, to be honest, we have covered those things already. So for example, we've done integers, and we should remember what integers are about. Integers refer to positive, negative numbers, and zero, right? And we learned some rules previously as it pertains to that. So we should know that when we have a positive and a negative, we get a negative. A positive times a positive is a positive. A negative times a negative is a positive. So these are the foundational rules that we need to keep in mind to move forward. So another thing is we have the first question. I just want to do a few of these just to make sure that we remember. So in this case, we have 9 times positive 4. Anybody have an idea of the answer? 9 times 4 is what? Let's do this quickly. If you want to plug it in your calculators, you can, but I would recommend you try to do it without your calculators just to strengthen your understanding. Hi, Makita, good afternoon. So we're just beginning, so you haven't missed anything for anyone else who joined us. So positive 36, excellent. Okay, let's look at C instead. Let's look at C. What would be my answer for C? In this case, we have -2 times -5. What is our answer? All of this is just a quick revision activity before we move forward. Excellent. Anybody agree? Positive 10. Very good, guys, because a negative times a negative is a positive. We must always keep that in mind. Oh boy, I'm a pen stick. Let me see if I could use my So we're gonna have a little bit of freezing for some strange reason between the internet and my computer, which is clearly very tired. So everything closed. What y'all seeing right now? Let me know if you're seeing the screen shut down as well on your end.
I'm seeing your desktop.
Okay then. Just give me one more minute. All right. Let me see what's happening here. So in the meantime, in between time, guys, just, relax, mentally prepare yourself for the session until I try to get this opened. Oh, look at here. Okay, I see what happened. All right. Okay. So I have to re-import the whole document again, but that's okay. That's all right. All right, just give me a minute, guys. Let me reload everything and then we're gonna begin, okay? Thank you so much for your patience. All right, got it up and running again. So I'm gonna reshare my screen now. All right. Let me see something here. All right, so we're back. So tell me what y'all seeing now, my good peoples. Let me know what y'all seeing at the moment. If you're now seeing the screen that we had before. Simplify. Okay, awesome. So let's keep it moving. So we said positive 10, which was correct. And let's look at D. What would our answer be for D? 6 times 7 is okay, so we have one answer. What you guys think? Is it positive 42 or negative 42? Because we know when we look at the numbers, 7 times 6 is 42, but we need to consider the signs, and a negative and a positive is a negative. Very good. All right. E, what is the answer for E, guys? Let me see if anybody can catch. Look at my girl. Anybody else? Very good, ladies. The answer is 0. Don't get caught up. Anything times 0 is 0. All right. So we're just going to move forward because, again, this is just a quick revision of what we would have done before. Similarly, we have the case of adding and subtracting integers. So I'm just going to pick a few. Let's look at I. So I'm going to circle it, and I want you guys to tell me what answer you think it is. For I, which is -2 minus 6 minus 5. So what do you guys think the answer for this one is? Take a try. Okay, so let's go through it. Remember the rules, right? Whenever you're subtracting from a negative number, and because we have 3 cases here, we're going to do it step by step. So if we're doing it step by step, we're going to subtract the first 2. When I subtract the first 2, -2 minus 6, what is the rules? When you subtract from a negative number, you add the 2 numbers and you put back the sign. Because remember, you're subtracting from a negative number where the signs are alike. Don't forget, very important. Answer would be -8 minus 5. Everybody see how I got that? Because -2 minus 6 is -8, and you bring back down the -5, minus 5. And so we go again. -8 minus 5, same rules. When the signs are like, you add the numbers and you put back the sign. So 8 plus 5 is 13, and we put back the sign -13. Okay, so if you didn't get that correct, that's okay. So it's for you to just remember the rules. So let's do a simple one. Let's do D. Let's do D quickly. What's the answer for D? Everyone, I need everybody to come and try. So let's go. What is the answer for -D? For D, sorry. All of this is us reinforcing our understanding, what we learned before, because this is extremely important in this topic. So the answer is -9. Excellent. The signs are like, you added 2 numbers, you put back the sign. All right, let's try the last one, J, which is more complicated, but we can take it step by step. So I want everybody to take a try. Take a try and tell me what you think the answer is. Also, remember to always make notes and write these examples in your book so that you have them to look back at. Okay, so I'm seeing -11. So let's take a look at it. Now, the first step, we do it step by step, right? So let's look at the -12 plus 7. Now, in this example, we should remember the rule that says when the signs are different, what should we do with the 2 numbers? We should subtract. So 12 minus 7 is 5. And the answer takes the sign of the bigger number. Who's bigger? 12 is bigger. So obviously our answer will become -5. And then we bring down 6. And we know this one is pretty simple. So we know that the signs are alike. So we add the two values, we get 11 and we put back the sign. So excellent job. That is the correct answer. All right. So remember, it's not about where you start, it's where you end. So hopefully that was a bit helpful in reminding us of the simple rules as it pertains to integers. All right. We have some examples here with clashing signs. So I just want to try one. -3 plus -3. Anybody want to try this one and tell me what they think the answer is? Even if you're not 100% sure. What do you think the answer for this is? We have some things we need to address first before we even add or subtract anything. But what do you have? What answer do you get? Okay, so one person said -6, -6. Anybody else? If you're not sure, that's okay. All right, so let's look at it. So when we look at a question like this, the first thing that should draw our attention is this clashing sign situation here. And we know when a positive and a negative come together, it becomes a negative. So our equation that we end up with is -3 subtract 3. We know the rules. Subtracting from a negative number, or when the signs are alike, you add the values, you put back the sign. So excellent job, excellent job. So we're keeping it moving. So we have some examples here, guys. So if you are going to review this on YouTube, what I recommend that you do is you pause it and you try some of these questions and see if you can get the correct answers. So I have the answers listed here for you to check yourself. So it's all about making sure that you are capable of getting these answers on your own. Questions like this require practice, so don't be too difficult or too hard on yourself, but that's for you to go. So let's go. We're going straight into algebra. So everybody head up. We're going to go into introductions. And I'm going to start off by having a verbal activity for us to clarify or have a better understanding of what happens in algebra. So essentially, in algebra, we use letters to represent values. And those values are numbers, obviously, but those values could be known values and unknown values. So here we have these two types of values, known and unknown. What do we mean by that though? So let's look at an example, and I want everybody to answer these questions. One, I have P number of fingers. I have P number of fingers. In this example, guys, I need you to tell me, is this a known value or unknown value? Do you know how much fingers you have? Look at your hand. Is that a value that you can count and figure out? Look at your hands. Tell me, count them. So tell me what the answer is. Exactly. So in this example, our letter, and we have names for them, but we just focusing about understanding when we have known and unknown values. So in this example, P has a value that is known, and we just say P is equal to what? 10. Because I know that I have 10 fingers. So if somebody say I have P number of fingers, I know that that means P is equal to 10. So in this case, P is known. Everybody understand that? Let me know, please. Because we're taking it nice and slow. We're taking it nice and slow. So let's go. Everybody let me know if you understand that example. We're going to use another one. Look at example 2. I have M number of parents. Is this known or unknown, guys? Is M a known value or unknown value? M is a known value because you know, and what's so special about this example though, is that M is a conditionally known value. Why? Because to be honest, some people can say M is 1, because some people can say, well, I have 1 parent, but some people can say I have 2. Everybody see that? So in this case, we realize it is possible for my value to be 1 or 2. But this is a special case. I like to make sure I give you all the examples. We don't really see much examples like this, guys, okay? This is a special case. This is just for you to know that it is possible, but it doesn't happen often, okay? All right, so let's look at some examples of some unknown values. So right now we're looking at letters that are represented by known and unknown values. 3. There are Q number of stars in the galaxy. Is this a known or unknown? Let's be real. Do anybody know the exact number of stars in the galaxy? Nobody. So in this case, Q is an unknown value. It just represents a quantity, but the truth is we don't know what a quantity is. So that's the first thing we understand. So to be honest, this is the basis of algebra. We use letters to represent quantities that in many cases that we know or are given or we don't know. So I'm gonna do we're gonna keep moving along. We're gonna do some definitions now. So this is time for us to write. Currently, it's gonna be a bit tricky, but maybe what we should do is go through it first and then we'll write after. So let's go through some more information first and then we will write after. All right, so my next slide here, we have algebra is the branch of mathematics in which symbols, usually common letters of the alphabet, also known as variables. So I'm going to underline this word. We're not going to write here. We're just going to pay attention. Variables are used to represent unknown numbers. And as we just realized, there are cases where it's also known numbers. So it's not just unknown numbers, it's also known numbers as well. So based on this chart, we're going to look at some definitions, some important words, but we're going to write out these definitions over, okay? This is just for us to see what we're talking about. So we have an algebraic expression. What is an algebraic expression? Look at the keyword here, algebra. That's your indicator word that we're dealing with algebra. It's just when you have a combination of numbers and letters together. So for example, we have 3y minus 4. Here we have the definitions of the terms in the expression. So if you realize the expression is a combination, it has what? Numbers, letters, and an operation. That's where you will get an expression. And this is where I need us to pay attention. The letters used in algebra are called variables. Don't worry, again, we're going to write over these notes in a clearer form. But this is just a table for us to look at some examples. So any letter that is used in algebra is called a variable. So in this example, our variable in the expression is y. Then we have a number. When a number stands by itself, that means it has no letter attached to it. It is called a constant. So we're going back. A variable is the letter. A number that stands by itself is called a constant. And I hope you guys are saying it out loud because I'm going to tell you now. Although maths is a lot of writing and numbers, when you say things out loud, it helps your mind to remember it. Okay, so as we go through, don't be afraid to call it out loud. Variables is the letter, constant is the number. Now, there's something I need you to pay attention to. This word called the coefficient. You're going to hear me talking about this word a lot in this topic. The coefficient is the number that comes just before a letter. So in this example, we have 3y. We already know that the y has a name. The y is called what? The variable, because that's the letter. But the 3 is called the coefficient. Why not the constant? Because it is attached to the variable. Okay, so let's look at another example. We're going to keep going, even if it's a bit confusing. Don't worry, we're going through the examples for persons who are learning for the first time. So let's look at our next expression. We have 9 minus 5x squared. So we have different elements in this expression. We have our operation, which is subtraction. That's the easy one. Then if we were to look at 9, what is 9, guys? Is 9 the variable, the constant, or the coefficient? 9 would be our constant because it stands by itself. It's just a single number. In this example, we realize we have minus 5x squared. Here, our variable will be x squared. And I want you to always remember, what does x squared represent? X squared simply means what? X times x. And some examples, remember 2 squared? What does 2 squared means? 2 times 2. What does 4 squared means? 4 times 4. Not because we're doing or using letters should we ever confuse or forget the meaning of a power. The power always tells us to multiply whatever it is by itself that number of times. Okay? And then we look at the coefficient. What would be the coefficient? -5. I want y'all to also pay attention. You realize even though this is the operation, when writing the coefficient, you realize the coefficient takes the sign right in front of it. Pay attention to that. Let's look at the next example. So we have something going on here, a more complicated example. We got 3 terms. This is your first term, your second term, your third term. How much operations do we have? 2. 1, 2. 2 would be our what, guys? What is our 2? 2 would be our constant, right? Because it stands alone. And I'm going to rewrite 8AB. In this example, you realize what? We have 2 letters here, A and B, but we're going to come to that and explain what this means. But all you need to remember is that our variable in this example is AB. And what would be our coefficient? The 8. So here's where we're going to take some notes now, and we're going to come back and look at everything we just looked at. So copy down this information for me, and we're going to go from there. So the first thing we're going to write is any letter used in algebra is called, let me write this in a different color, a variable. I'm going to give you some examples. So it can be a single letter. For example, X is an example of a variable. A by itself is an example of a variable, but then you could have a combination of variables that make one. So for example, like we saw before, AB is considered one variable. P square is also another variable. MPQ is also a variable. Okay? We're going to come down and we're going to look at constant. So right now, your main focus is remembering these terms. What is a variable? The letter by itself. What is the constant? The number by itself. What is the coefficient? When there's a number that comes just before your variable. So we're moving on to number 2, which is the constant. Any number that stands on its own. So example would just be, and it could be positive or negative, okay? So you have 3, -12. Sometimes it's even a fraction, a half, -4/3. Once it's a number by itself, guys, it is considered a constant. So let me just write this above. A constant. And the third one we just learned is the variable. Not the variable, the coefficient. So 3, the coefficient. So I'm gonna let y'all know, most times people is confuse the two. So it's really important for you to make sure you understand the difference between the constant and the coefficient. So I'm going to use a different color to represent the coefficient. So if I got 3, P. Let me try M. -2. So in this example, 3 is the coefficient. And in this example, -2 is the coefficient. All right. And just a quick check to see or to confirm that we get it. I'm gonna just do a quick question on this side. So I'm gonna write an equation. I'm gonna write it in yellow. All right. So I'm gonna ask a question to see if we understand or if we're gonna be thinking. So let's look in this example, guys. My question to you is, how many variables do we have in this expression? So we're looking at this expression here, 2p plus m, 2p plus 3 plus m. How many variables? 2 persons responded. How many variables do we have in this question? Look at it. Remember, you're always open to changing your answer. How many variables? Okay. So when you see a question like this, the first thing you have to ask yourself, another way to ask the same question is how much letters? So then I'm going to ask it a different way, because remember, variables just mean the letters in the equation. How many different letters do you see? So let's see. I see a P. So that's 1, and I see an M, that's another 1. So that means there are 2 variables in this equation or this expression. It's not an equation, it's an expression. And I'm going to show you the difference between equations and expressions. And those 2 variables are P and M. Everybody see it? So if you didn't get it the first time, that's okay. My next question is, how many constants? Excellent. An expression is without the equal sign. Once you add an equal sign, then it becomes an equation. That's where you would hear equal, equation. Very good observation. So let me ask the question again. How many constants do I have here? And keeping in mind, A constant is a number that stands alone. That means there is no letter attached to it. So there's one constant. So please make sure you copy down this example and write down these answers. So our one constant is what? What is the constant? Is it the 2 or the 3? Because I got to make sure. Excellent. So there's one constant. Very good. So the constant is 3. Now my question is there any coefficients? Is there a coefficient in this expression? What is the coefficient in this expression? Very good. So 2, there's one coefficient and 2 is the coefficient. All right, so that means we should understand these terminologies when it comes time to work out these questions. So we're gonna be moving on to the next step. But copy this down and let me know when y'all done, please. Thank you. So I just want to also keep you guys aware of, so we have algebraic expression. We have something called algebraic terms, and an algebraic term is just any term that has a letter in it. So 2p is the algebraic term. M is the algebraic term. 3 is just a constant because it's just a number. Okay. We're gonna look at some other information and some other notes. So that's 2 persons who are done. I'm just gonna give you guys another minute to write down. Okay, awesome. So we're gonna write some more notes. So, given any algebraic terms, I'm gonna give you guys some examples of algebraic terms. So that's what we're looking at now. This is supposed to be an E. So I'm going to give you 2 examples. So I'm going to give you 1, 2, A. I'm going to give you another one, minus 3, B. I'm going to give you another one, 4. Oh, no, I have an idea. Not 4. I'm just going to give you M squared. So look at these 3 very different examples, all examples of algebraic terms. Why are they algebraic terms? Because they all incorporate a letter in them. There's some parts that we need to pay attention when we look at algebraic terms. I'm going to write them down, and then we're going to evaluate each and see if we could identify the different parts. So the first parts that we're going to look, so parts of the algebraic term. The first thing you have to look for, 1, the sign. What do you think I mean by the sign, guys? Who could tell me what this means? When you say the sign, what does that mean? When you ask for the sign of something, what are you looking at? Very good. You're looking at if it is positive or negative. So let me write out the word positive or negative, because each term is either positive or negative. So that's the first thing you look for. And I hope while you write each part, you look at the examples and see if you could identify whether it is positive or negative, okay? The second thing you need to look at the coefficient, because every algebraic term has a coefficient. Some of them are directly indicated, some of them are indirectly indicated. 3, you need to look at the variable. Sometimes we have single variables, sometimes we have compound variables. That means more than one. And 4, So I want to add another example here, but I'm going to wait. And the last thing you need to look at for every variable or every algebraic term is the power. And another word for the power. Who could tell me the next word for a power? We learned a lot about this before. One of the words starts with an I. Another word for power starts with an E. So what's the other words for power? Because remember, we need to remember that all of it means the same thing. Anybody remember the I word for power? How do we say power using the word with I? Index. And I want you to know that index is the singular word for indices. So the plural word for indices is the plural word for index is indices. So it's the same word. Just the index means one power, indices mean more than one power. Anybody know the word with E that means power? Yes, speaker. Very good. It's exponents. And I'm going to tell you a joke, right? This exam gone, we were talking about it because I have some students who will be, they feel like they fail, so they want to re-register with me. And I was discussing with them some questions. And I said the word exponent. We was reading and the word exponents come up and they were like, Miss V, I never see that word in my life. When they find out it just means power, they wanted to cry. And this does happen all the time. As simple as it is, one word could throw off your whole entire life. So always try as much as you can to remember every word that you are taught, because that is where it makes the huge difference in your learning. So indices, sorry about that, the pen. INDICIES. So we have the power, the index or the indices, and exponents. So these are the 4 things we need to look at. And so I'm going to add one more example. I'm going to add 2PQ. All right, so let's take it here because remember today is just our introduction to algebra. So Trev, you see it? You have it now? So let's go back through the 4 different parts of every single term. So if we look at, we have 4 different algebraic terms. We have 2a, we have negative 3b, we have m squared, and we have 2pq. Every single one of these terms have all 4. And it is important for you to be able to identify them. So let's look at the first one. Whether you feel confident or not, I still need you to try. So we're going to start off with 2a. So I'm going to come on the side here. So I'm going to come to the side here. We're going to go through the list and we're going to identify it. So let's go. So the first one, 2a. Is 2a positive or negative, guys? So one person sent me the answer already. So that's a positive term. So we got positive. Let's go. What is the coefficient? What is the coefficient? Excellent, 2, because 2 is the number that comes in front of the letter. Next one, what is the variable? Excellent, A. Now this is the trick part now, and I'm not going to tell you what is the power, because we did learn this before, just in a different topic. No, look at it. The power of the variable. Y'all remember when we did place values? Remember when we did ones, tens, hundreds, thousands? You remember we were looking at the impact of the power of 1. So let me look at this. Let's do some examples. If I have 2 by itself, 2 and the power of 1, so it would just be 2. Right or wrong? But because this is an understanding, why should I put this power here if I don't know this 2 by itself just means 1, 2? So in maths, anytime you see any number, 3 really means 3 to the power of 1. 10 really means 10 to the power of 1. A by itself means it's just a to the power of 1. Everybody understand that? So anytime there's a single variable, and even though there's no power, the power is 1. Once the letter is there or the number is there, the power is 1. And I'm going to show you, Myrtle, not now, but hopefully on Wednesday, because that's the next class. I'm going to show you what anything to the power of 0 is. I'm going to teach you that after. But I need everybody to tell me if they understand this concept. So anything by itself, so any constant or letter by itself has a power of 1. It's understood. They don't expect you to go put a 1 here because they already know 2 by itself is already 2 just by itself, 2 ones. 3 to the power of 1 is just 3. You only got 1 3. 10 to the power of 1 is only 1 10, so it's just 10. A to the power of 1 is just 1A, so it's just A. So one person responded yes. Everybody else? Talk to me. Talk to me. If you don't get it now, don't worry. We got more examples to solidify the content, okay? Let's look at the second example. The second example, I'm going to write it to the above here, 3, -3b. So let's break this one down. Let's start from the top. What do you always look at? The sign. Here, what is the sign for this first example? Excellent. So it's negative. Good. Coefficients. What is the coefficient? Very good. Is it 3? Is it just 3? -3. Don't forget that sign. That's a trick question. The negative sign is attached to this 3 here. They come together as 1. All right. And this is the thing that has tripped everybody up in algebra. So that's why we're taking it slow with this aspect. All right. Let's go. What is the variable? That should be easy. Very good. That's 1 person. That's 2. Come on, guys. What's the variable? Very good. B. Last one. What is the power? And it always asks you the power of the variable. The power of this variable is 1 because it's B by itself. Excellent job. Excellent job. So we move in. All of this is foundation. All of this is basic foundation information. Let's look at M squared. Now this is the trick one. So I want us to focus, okay? So let's go through the checklist again. Positive or negative? Always ask yourself, what is the sign? Is it positive or negative? Excellent. Positive. Next thing you're looking for, the coefficient. I tell you now, I know. This is the trick. Talk to me. I want y'all to tell me. I'm going to move this over by itself. Oh, it can't go across. No more, it could only go down. I'm going to show you something. I am going to say that A represents the number of apples. Y'all ready? A represents the number of apples. If I just write A by itself, how much apples is that? One. Not because I ain't put 1A. If I just drop a P, how much P's you got there? Just 1. So you see the difference now, guys? This is another part that is understood. So let me show you a trick. If I put A, it's really like this, you know, the coefficient is actually 1 and the power is actually 1. But in maths, this is understood. So we don't put the power of 1 and we don't put the coefficient as 1. But it is understood that a single variable standing on its own is 1. So P is really what? 1P. The coefficient is 1 because 1P there by itself. If I got Q, is 1Q I got. But I don't need to put this 1 here because I understand it's just 1Q I have. Very good. That's what we're doing. We understanding and we're learning the difference. Because once you understand, maths is a language. You understand? When you just got to learn to speak the language. When you learn to speak the language, you'll be able to interpret. You'll be able to read. You'll be able to understand. You'll be able to understand questions. All right. So let's go back up. Now that we understand where we got, if you put a 1, you wouldn't get it wrong. Thank you. So somebody asks, if I were to put a 1, do I get it wrong? No. But the truth is, this is like content that they look and expect you to know. They don't expect you to write 1A because they expect you to know that A is an understood 1 to the power of 1. So I would accept it in the beginning, but as we progress, this is something I don't expect to see from you guys, okay? So let's keep it moving. So we know the coefficient of m squared, I hope you are writing these down. Please make sure you write these down, is 1. Let's look at the variable. What is the variable? This is a trick question too. So Makita said M, Myrtle said M2. Very good. Very good, guys. And I'm going to show you why Makita. M square represents a variable, you know what variable that represents? What does that represent? It represents M times M. You see why it cannot be M? No problem. Thank you for letting me know, Ashley. You could always look at the video when it's posted on YouTube by tomorrow. So back to this. Makita, you see why it can't be M? If you put M, M does not suggest M square, because what does M square suggest? M square means M times M. So the whole thing is the variable. M square is the variable. And so the last thing we need to look at is the power or the index or the exponent. What is the power or the index or the exponent? 2. Very good. Very good. Last one before we move further along in our notes. Hi, Zamarian. Welcome. I think you missed the first half, but that's okay. We haven't gotten too deep into anything. So you missed some notes, so just follow along for now, and then you could always use the videos to copy down the rest of your notes, okay? So last one, what we're looking at is identifying the different parts of algebraic terms. So let's look at 2PQ. So this is another challenge here, guys. This is another challenge here. What is the sign? So we got this term. This is a term, algebraic term, because it have these letters. So it have these 4 parts. What is the sign for this one? Is it positive or negative? Very good. Positive. What's the next thing we got to look at? What is the coefficient of the term? Myrtle said 2. What everybody think? Is it 2? Very good. 2. What is the variable now? Let's see if we can see that. What is the variable? Very good. PQ. This is an example of a double letter variable, P and Q. Last but not least, don't get tricked. What is my power? Very good. But here's what I want you to realize. How many variables do we have here? We have 2 variables. So that means we really have 2 powers to consider. So our power is 1, but it's for both P to the power of 1, and Q to the power of 1. Because there are examples where the power could be different for both of them. So I need you to pay attention to that. The power is 1, but the power is 1 for both the P and the Q. Everybody see that? Excellent. So we're going to continue with some notes. These are some things we need to make note of. In math, if I see 2A, do you know that this means 2 times A? If I say I got 2 apples, how much apples do I have? 2 of them, 2 times apples. If I say I have 4M, 4M means 4 times M. If I have AB, in algebra, this means A times B. When you multiply letters in algebra, or what do we call letters? Variable, you're really just joining them together. This is another rule you need to know. So when you're multiplying a constant and a variable, you join them together, you get 2A. So 4 times M is 4M. 2 times A is 2A. 4 times M is 4M. A times B is AB. So my question to you is, what would my answer be for this? But what do you realize? Is A and B alike? They are not alike. So the rule is when you multiply two different variables, you join the letters. So I'm going to write that below here. When you multiply two different variables, you simply attach the letters or join the letters. Two variables, you simply, so from now on, guys, as we go further, it's going to get a bit more challenging. I wouldn't even say challenging. I would just say you would realize it's becoming more complex, okay? You simply join variables. The key word here is different because there's not a set of rules if it is the same variable. So I'm going to underline, please underline different. And the truth is it could be 3 or 4, it doesn't matter. So I should really put 2 or more. So anytime you're multiplying 2 or more different variables, you simply join it. So let's look at an example. Oh, I didn't realize I had this here so big. So let's go to the side. And then we're moving on to our other slide. So I have this question for you guys. Quick popping quiz. A times B times C. What is my answer? Let me see if we're thinking. A times B times C. Excellent. That's it. That is it. It is just A, B, C. So that's what we need to remember. A, B, C. All right. So let me know if you guys have finished copying down these notes. I am expanding it a bit for you to see. If you don't get it, you can also back check the YouTube video to continue writing. But I just want to recap a few things that we did before we move forward. The first thing that we looked at is the different terms for each item in an expression. So we looked at a letter. A letter by itself is called a constant. So in this example that we looked at, the 3 was the constant. Then we have the coefficient, and the coefficient is the number that comes in front of the variable that is attached directly to the variable. So here, our coefficient was 2. And then we have our variable, which is any letter that is represented or used in our expression. So here we got 2 variables, P and M. Then we moved on to looking at the different parts of our algebraic terms. So whenever you see an algebraic terms, these are the 4 things you always have to check. You check for the sign. Is it positive or negative? You check for the coefficient. Is there any? There always is. Guys, there always is. Even when it's not written, we know that if it's not written, for example, with M square, the coefficient is 1. Then we look at the variable. Sometimes it could be a single variable like A, or it could be a doubled variable like PQ. Then we look at the power. Another word for power is index or indices, remembering that indices is just the plural form of index. Same word. One is singular, one is plural. And the next word for power is exponents. All right. And then we looked at a few examples identifying those different parts, because if you don't know the parts, when it comes to adding, subtracting, multiplying, dividing, you are going to have a challenge. All right. And then we looked at 2 basic rules. When you multiply a constant and a variable, you attach them. So 2 times A is 2A. When you multiply 2 different variables, the same rule applies, you attach them. So A times B is AB. All right. Everybody, are we locked? Good to go? Good to go, good to go. Excellent job. Hopefully you guys are not feeling too overwhelmed. Hopefully you're feeling a little bit comfortable, even if it's a bit blurry. So we're gonna move right along. So this is where I'm gonna tell you, see this, when I saw the exam, I smiled because I did this with some of my fourth farmers who sat the exam with another teacher, but we did this in class. And they told me, Ms. V, if you didn't do that with us, we would have never answered the question. See, he sent a question just like this. And so much people leave the question unanswered. And y'all gonna see how easy it is. So let's look at it. Here, we're going to take these algebraic terms that are expressed as sentences, and we have to write it as expressions. Before we look at these examples, we're going to look at some simpler versions because, you know, we have to build our way there. So I am going to say there are two numbers. So I'm going to just verbally give you guys this one and show you the answer. So listen and pay attention. There are two numbers, A and B. So I'm going to write my two numbers, A and B. What is the sum of those numbers? Who could tell me what sum means again? What is sum? When you're finding the sum of something, what does that mean? To add. So if I am asking you to find the sum of two numbers, and the truth is, I chose A and B, but guess what? You could choose any two variables, any two letters in the alphabet, it does not matter. When you are creating it, you could choose. Sometimes CXC will literally tell you, oh, the two numbers is A and B. So in that case, you don't have to make it up. But in general, I am using A and B. So how would I write this? I would write this as A plus B, because my two numbers, the first number is A and my second number is B. I have a question for you. Are these two variables known or unknown? Are these two variables, guys, known or unknown? Excellent, because I ain't give you no value for them. I ain't tell you what they're representing. So you realize that in math, sometimes you're doing an investigation for two numbers. And you're just writing down two letters to represent these two unknown values. But we know that sum means to add, so we just say A plus B. So I'm going to ask you some questions and I want you to type the answer. I'm not going to write it. I'm going to say it. So get ready. What is the product of two numbers, P and Q? What is the product? How do you write an expression for the product of two numbers, P and Q? Okay, then I see somebody level up. Oh, because I just teach you this. I just taught you what is the rule when you multiply two variables. So the answer is correctly P times Q, but would you think you would get full marks for that? You will not, because you just learned that when you multiply two different variables, what do you write the answer as? PQ. This is where now, guys, remember we spoke about making connections? This is where we make the connections. You learn one thing in one bubble, you learn something else in another bubble. That does not mean they're not connected. So always think that way. Always ask yourself, would this rule apply here? Yes or no? Okay. My job is to teach you how to think. So that's what we're going to do. Let's do another one. The product of three numbers, STV. What is the product of three numbers? STV. What is the product of three numbers? STV. Okay, I see some people trying. So we should remember that product means to multiply, right? So it means we're multiplying S times T. If you use a different letter, that's okay. My accent maybe send the wrong sound, but it's T I was saying. So S times T times V. But our answer would be what? STV. Because what is the rule? When you multiply variables that are different, your answer is just joining those letters together. So let's see, that was the basics. So let's take it up a notch. Let's see if we could figure out the equations or the expressions, because remember, equations involve the equal sign, expressions do not. So let's look. Okay, this is so complicated. A lot of musty. Let's do our next example before. 7 times a number A. How do I write 7 times a number A? That's 2 persons send their answers. 7 times a number A, that's 3. That's 4. Very good. So if you got 7 times a number A, and you learn that when you multiply a constant and a variable, you join them as well. So your answer is 7A. Very good, everyone. Very good. So for those persons who are just watching, that's good. That's no problem, but don't be afraid to try. So now we're going to kick it up a next notch. We're going advanced now. We're going to take it slow. So we're going to do the first one together because I'm going to show you how you should be thinking, and then we're going to try the others on your own. So let's go. The first thing says 7 times a number B plus a second number H. So let's take it step by step. So the first part, it says 7 times a number A, 7 times a number B. So what would that be, guys? 7 times B, right? Plus a second number H. Makide, you're correct. Yeah, I got you. So here we know 7 times B is what? 7B plus H. Boom, this is our expression. Everybody see that? Okay. Number 2 is way harder. So every question gonna be more difficult, but we're gonna take it step by step. This question now says, sorry guys, my accent kind of weird, man. I'm sorry, my bad. I'm trying. I'm gonna try to speak more clearly and whatnot. You know what I'm saying? If I speak like American, would that help? Okay, no, let me stop. Sorry about that. So let's look at number 2. 3/4 of the product of 2 numbers M and H. So let's break it down. This is where you know you have to use your pencil and you're gonna break it down. Because this one a bit, intense. They want you to find 3/4, the product. So that means before you even find the next piece, you need to find something first, because you need to find 3/4 of something. So let's find that part first. So it says the product of 2 numbers, M and W. How do we find the product of M and W? M times W. You put that in brackets, right? Because remember we learned when you're trying to find something of something, you have to put it in brackets. So you want to find 3/4 of that. How do we find 3/4 of that? You remember we did this? 3/4. What does of mean? To times. But do we need to put a times outside the brackets? No, because we learn that anything outside the bracket mean you just multiply everything outside by everything inside. But can I make this simpler? Yes. It is 3/4 of simply MW. But you have to put this in brackets. You know why? Because if you leave it just like that, it's suggesting that you're finding 3/4 of M and then you're multiplying it by W. If you ain't catch this one yet, that's okay. Don't stress yourself too much. This is all about exposure. So if that one was a bit rough, that's all right. Let's look at the next one. The next one says, let's give some space for this one. We need some space. So let's read it. 6 times the product of 2 numbers, P, hear me about P now, D and P, less 5 divided by thrice a third number C. How I feel about this one? Let's leave number 3 for last. Let's look at number 5. I want everybody to try number 5. Let's look at number 5. Number 5 says, so we're gonna go down and come back up. So let's do number 5. 5 times the sum of X and Y. How y'all would do that first? Which part would you do first, guys? It says 5 times the sum of X and Y. The sum of X and Y. What does the sum of X and Y look like? How do I write the sum? So I'm going to focus on this part. The sum of X and Y. How do I write the sum of X and Y? X plus Y, because we know sum means to add, right? And then they ask us for 5 times that, but they ask us for 5 times all of it. That is why we will put our brackets and put our 5 outside. That's what I'm talking about, my peoples. That's it right there. Everybody understand this? Everybody feel okay with that one? That one is pretty simple, straight to the point. Let's try number 4. 4 times a number Y less twice a number G. Try that one for me. That one is also really easy. That one is pretty easy. 4 times a number Y less twice a number G. Let me see who gonna get it. Let me see who gonna get it. I check in the chat. I want to see what y'all think. Let's go. If you don't know, just type don't know, not sure. Okay, so one person tell me they don't know. What about everybody else? Remember, communication is key. We're gonna do it together. So let's break it up. It's all about breaking it up. Okay, so I see some options, not sure. So let's take it step by step, right, guys? Let's break it up. So let's read the first part. It says 4 times a number Y. So before we move on, how do I write 4 times a number Y? I'm gonna do it right above it so that you could see. So that means we could do this first part here. What is this first part here? 4 times a number Y. How do I write that? 4 times a number Y. Excellent. Everybody see that? Then it says less. How do we write less? What operation is less? How you find something less than something? To subtract, right? So it's to subtract. You don't try to jump straight to the answer. When you try to jump straight to the answer, that's where it becomes complicated. You take it one step at a time. So you subtract. Then we're looking, what is it we're subtracting? Twice a next number G. How do we write 2 times the next number G? 2 times G. But this could break down more because 4 times Y is what? 4Y. You put back the subtraction sign. And 2 times G is 2G. So excellent to those persons who tried and got it right. Excellent work to those persons who just tried in general, even if you didn't get it right. I hope you guys are copying down these examples. This is very, very, very important to know. Like I told y'all, a whole question come like this. And you know what was so crazy? This question had a part A, a part B, a part C. So if you couldn't get the expression, so let's, for example, say this was the expression. If you didn't get this part right, everything else after that you got wrong because you needed this equation to answer the other questions. And the first questions was just like this. They came just like that. So let's look at the monster question. Okay, let's take a deep breath. Let's see if we could work on it together. Oh no, I can't see now. So let's look at C and see if we could work on it together. Let me see if anybody want to try with me. 6 times the product of 2 numbers, D and P. So that's 1. That's 1 part here. Can we get this part though? Anybody want to try at this part? What would this part be? The first part. 6 times the product of 2 numbers, D and P. So let's write it down. 6 times the product of D and P. So what is the product of D and P? D times P. But I could simplify this because it would just be 6 times DP. And how do we write 6 times DP? Remember, the product means to multiply. Makita, you're looking good though. I'm not gonna lie. You're looking kind of good. You're kind of looking good. Let's see. So 6 times DP. What is my answer? Just 6 DP. Remember when we learned about multiplying a constant and a variable, you just join all of it together. So this is the answer for the first part. I'm going to use another letter. So we got the first part down. So this is the first part of our equation. 6 PD. Everybody gets how we got that first part? Remember, it just said what? 6 times the product, and product means to multiply. The product of two numbers, DNP. And the product of DNP is just DP. So you multiply 6 times DP, which is 6 DP. So that's part 1. Let's look at part 2. Less 5. How do we represent less 5, guys? Anybody, everybody, how do you represent to less 5? You just minus 5. You subtract 5. That's it. So we got our second part done. That part was easy. The third part now, this is what the third part says. All of that divided by a third number thrice. Jesus Christ. What thrice mean? If twice mean 2 times, what does thrice mean? If twice is 2 times, thrice is 3 times. So that means we are dividing all of this. And you know, that's how we just write with division sign, right? That's one way to write it. And I'm going to show y'all another way to write it. So you put all of this over, could that mean divided by 3 times a third number C. How do we write 3 times C? How do we write 3 times C? What is the answer for 3 times C? 3C. Very good. Very good. So guess what? That's it. This is the answer here in yellow, guys. That's it. That's it. And there's another way you could write this down. So I saw some of you have it there. So I tell you, very close. You was very, very close. So if this question was on 3, you would have get 2 out of 3. So another way to write this is just by writing. Actually, I taught y'all this. How can I rewrite this? When we was doing fractions, I taught y'all how to rewrite this. How do you rewrite this? Using a linear way. When I say linear, in one long line. When we were doing our fraction questions, I always showed you both ways. This way where you have it one on top the other, or when you do the division using the linear way. Anybody remember? So I'm gonna write it. Let me see if you remember. Minus 5. All you have to do is put this in bracket, because remember, this means you have to do this first, and then you put your division sign, and then you put 3C. That's it. Everybody remember that? Please don't forget, even though you see we're doing another topic and it's the same thing, you see that we're using the same concept in a different topic. We're not doing fractions, but in the same concept that we learned in fractions of rewriting these terms in different forms. So always make sure you have both, okay? All right. I think we have 2 or more questions, examples like this, but I hope that you guys kind of have a grasp. We will do some more practice with this because, like I told y'all, CXC dropped this last year and everybody was in shambles because this is something you will learn in third form and never see again. So CXC must say, oh, okay, I think I know what we're doing. Take this, boom. All right, so let's keep it moving. So let me just open this up. Don't forget, if you haven't finished copying it down, you can do so using the YouTube link. But I hope you guys feel a little bit more clear on this. So before we move on, let's look at 2 more. Let's look at 2 more. And then the rest I would like y'all to do for homework and send it to me. So we're going to do 6 and 7. And then you're going to do 8, 9, and 10 individually and send it to me. I just want to take this opportunity to say that, you see, when I ask y'all to do things like this and y'all don't do it, you're the one who's suffering because you're not going to be benefiting from extra practice. It is your responsibility to do these things because it's going to strengthen your skills. All right. Okay, so let's look at number 6. The sum of 2 consecutive, no, this is where I'm going to teach you this because you're not going to know this. So this is something that comes as well in multiple choice and even on paper too. And when people see this, they just get confused, but you have to know this. What does consecutive mean in general? Who could give me 2 consecutive numbers, just in general? Any 2 consecutive numbers? Give me an example of 2 consecutive numbers. When you hear that, what comes to mind? Very good, Cloris, 1 and 2, 2 and 3. It means one after the other. What do you realize about those 2 numbers? So let's look at 2 and 3. What do you realize about 2 and 3? Anybody could tell me what they realize about 2 and 3? What is the second number in relation to the first number? Excellent, Makida. Very good. That's what consecutive means. Consecutive means next. How do we get the next number from one number in math? You add 1, because to move from 2 to 3, I have to add 1. So let's say we want a general representation of 2 consecutive number. So if my first number is going to be A, what would be my second number? We just see how to move from one number to the next. So what would be my second number? No, don't look at it as A, B, C. I just tell you, A is my first number, and to move from one number to the next, we add 1. So your second number is going to be A plus 1. This simple concept here, very important. Guess what? Can I use different letters? I can. So if I have B, what would be my next number after B? B plus 1. Remember, C is a whole next number we don't know, so we can't use C. We can't use B. We have to use A, because A represents that one number. And what would be the number plus 1 after it? Just A plus 1. So let me tell you, let's look at this then. Let's use A and A plus 1. If I tell you A is equal to 3, what would be my next number then? So A is 3, what would be my next number? 3 plus 1, right? Which is what? 4. But if you go and write this, if I tell you A is 3 and you have this, you have A and you got B. You're going to put 3 here, but you're going to put B here. Can B tell you anything? B can't tell you nothing, because B is a whole next number. Everybody understand this simple, but very complex concept? So let's do a next one again. You see how this is where we go from basic maths content to level up content. So let me just see if I can switch over. My pen not working with me. I need to erase this. Guys, how y'all feel about that? Y'all in shambles or y'all all right? Talk to me. Y'all okay? Get in there. Get in there. So I want y'all to write this down for me as notes, because this is something you need to memorize. This is very important. This is very, very important, actually. So we're going to take a pause, and I want y'all to take note of this in your books. I'm actually proud of y'all, because algebra, like I tell you, is a very scary topic for a lot of people. And I think you guys are handling it so fast, so well. Y'all actually really impressing me right now. So I hope you can keep this up. In algebra, we represent consecutive numbers by let me run some tunes in the meantime. And then what time it is, I think we're going to end off. I just want to teach y'all some rules. And then Wednesday, we're going to get deeper into the content. So in algebra, we represent consecutive. And remember, if you need to write down a small definition of a consecutive, I can't spell for nothing there, so a lot of mercy. Consecutive numbers by the following. So if you choose the letter A as your first number, your consecutive number would be A plus 1. Who could tell me what would be the next number that come after, just for fun? If we got 1, A plus 1, what would be the next one? Excellent. A plus 2 would be the next number in line. Let's use a different letter. So this is example 1. This is just using one letter. Let's use P. So if the first letter is P, what will be the next number after P? Is it P1? P plus 1. And so the next number would be P plus 2. Okay? One more example using a different letter. Let's use M. So if M is our first number, our next number is M plus 1. And our next following number is M plus 2. So copy this down. Let me know when y'all done. All right. Yep. I did some paper 1 drilling and I saw some questions that came just like this. So I always try to keep updates with their general CXC has a trend, but then you can't trust them because you see what happened is a lot of people is only study to pass the exam rather than study to understand. And I think a lot, I'm not gonna lie to y'all, like I feel like the last exam, a lot of people gonna either just scrape the pass or not make it over the line because the way CXC just changed the whole structure of the exam. And they used a lot of worded problems, So right now, our major focus is to develop, and we're gonna look at M3 and M6. We're gonna look at examples like that. But definitely, guys, that's why it's very important for you guys to learn and understand and develop your thinking. So no matter what comes, you already have an idea of how you should go about answering the questions, okay? Now, even if you're doing other subject areas, honestly, only subject areas you should like study and memorize is like business subjects because there's a lot of definitions. What's another subject you could cram for? I don't know how accounting is. I don't know. But okay, so somebody said there are issues that they overthink. You see, if you set up a system in your mind and you stick to the system, it's going to help. Okay, so let's look at this example now. Oh yeah, HSB is a cramming subject for sure. I'll tell you another subject like that, chemistry, but then chemistry has one section where you have to really like learn. If anybody here ever did sciences, you know, like biologies look like a cramming subject as well. Okay, so let's look at this question now. The sum of 2 consecutive whole numbers when the smaller one is M. Okay, this is easy. Come, let's go. Come. They say, how do you find the sum of 2 consecutive whole numbers when the smaller one is M? So first of all, what are the 2 consecutive numbers? We did this just now. So if the smaller one is M, what's the next one? Excellent. And so they're asking us to find the sum of M plus M plus 1. Look at that. Everybody see that? So they asked for the sum. And remember, sum means to add. And the 2 consecutive numbers where the smaller one is M. So if M is the smaller one, M plus 1 is the bigger one. And you just add both of them. Very good. I like how this one is now. Let's go. The product of 2 consecutive natural numbers when the smaller one is K. For now, don't stress yourself about simplifying it. What is the working? How do I write this out? So remember, I just said don't try to simplify because that's rules we ain't do yet. But what would you write if you have to find the product of 2 consecutive numbers when K is the smaller number? What are those 2 numbers first of all? If K is a smaller one, what is the next one? So K and K plus 1. And product means to do what? Times. That's it. Excelente. Muy bien. I'm so proud. Let's do the next one. The sum of two consecutive whole numbers when the oh God. No, I like this one. So let me ask I this now. Here's this one. Is this the same question? Look at what it's saying now. It says you have two consecutive numbers when the larger one is W now. So I have a question for you. Let's look at an example. Let's look at 5 and 6. Okay, there. Is it negative W? Close. You're in the neighborhood, but you ain't reached the house. Just like how we had to add 1 for the next one. So to move from 5 to 6, we had to add 1. How do we move from 6 to 5? Let me see who's thinking. How do we move from 6 to 5? Exactly. Exactly. So if they're saying the bigger one is W, so let me write W for 6. How do I represent 5 then? What would be 5? Okay then. Okay then. Okay then. So in the first example that we learn about forward consecutive. That means the number and the bigger one after. This one means the backward consecutive, where you got the bigger one and you got to get a smaller one. Everybody see that? So that means W minus 1 and W are also consecutive numbers. So let's look at what the question is asking us to find. It asks us to find the sum, guys, the sum. Makito. So try it again. You want the sum of the two consecutive numbers. So instead of a multiply there, what should you have? And the next thing is, which one you think you should write first? If you're doing it in order, who is the smaller one and who is the bigger one? Don't you always write the smaller one first? So you have to be very careful. You're close, eh? You're close. So everybody, this is how we would have it, because we know the two consecutive numbers where W is the biggest one is what? W minus 1 and W. Agreed? And they ask us to find the sum. So that means what we're going to do in between here, add. So we should be getting closer. Let's try the next one, guys. The product of the two consecutive numbers where Y is the largest one. Let's go. Somebody try for me, please. Let me see some effort. Let me see some trying. Even if you get it wrong, when you try, you learn and you understand. First of all, let's identify it. If we have Y, okay, that's 2 persons in it. So I got an answer from Ambika. Remember, you could send me your answer directly. You don't have to send it to the group. So what about my other peoples? Are you still here with me? Are you just looking on and learning? That's perfectly fine as well. But don't ever hesitate to also make your own contribution. Wait, product is multiply. Yup. Don't forget, sum is to add. Difference is to subtract. Product is to multiply. Quotient is to divide. Okay, so let's check it out. Keeping in mind, which one gonna come first? The smaller one gonna come first. So who gonna come first? If you have two consecutive numbers, where Y is the biggest one. So if we know Y is the biggest one, who is the smaller one? Y minus 1. That's why we gotta write it first, is the details. So even though generally what you are writing is correct, you will lose I don't know, depends on CXC, but you don't want to leave nothing for chance. Everybody with me? That is why we have to write Y minus 1 first, because Y minus 1 represents a smaller value. So your answer is Y minus 1 times Y. To be honest, it's the same thing. To be honest, I'm gonna be honest with you, it is the same thing. But remember, they pay attention to every single thing. You take nothing for chance. When they want two consecutive numbers, it means how do we represent consecutive numbers? The smaller one and then the bigger one. So you always look at that, even though you're using letters, what is the smaller one of the two? The Y minus 1. Okay, that's why it comes first. So let's do the last one. 5 times the difference of P and Q. Everybody should be able to do this. Easy peasy lemon squeezy. What is that? 5 times the difference of P and Q. What difference mean again? I just said so. I just said so. Excellent, my people. Excellent, excellent. So the first thing you have to realize is that you're multiplying 5 times something. What is that something? The something is the difference between P and Q. So how do we write that? P minus Q. And this comes as 1. And so you're multiplying 5 by it. That's why we put the 5 outside. So excellent work, my awesome people. There's one note that I want you to write down for me that we spoke about before, but I want you to write it down in official notes. So copy this down. And then we're just going to do one more activity or one more new topic, and then that's it for the day. So this is something I want you to write about the coefficients. So you write note, and I recommend that you write this in a bright color. You could even put it in a box in a bright color, but this is something you need to remember.
Miss B, you could please read it out?
Okay, yes, love. It says, if there is no coefficient, then the coefficient is 1. Example, A is equal to 1A. P is equal to 1P. Okay, that's 1. 2, if there is no power. So the next one says, if there is no power, and you know what I mean, right? If you have the term and you don't see a power, there still is a power. So if there's no power, the power is 1. Example, M is really M to the power of 1. S is really the same thing as S to the power of 1. And then, like I told you before, you just put a box. This is just for us to remember. This is an important rule. Thank you very much. Muchas gracias. Good looking out. Good looking out. Good looking out. That's very important. Very, very good. I don't know why I have a red pen now, but it's 1P. And I should have put the 1 in red so that you could see the 1. Yeah, put the 1 in a different color so you could see. Just put this as a 1 so you can see it's a 1. All right, so let me know when y'all finish, my good people, and then we're doing one last thing and then we're done for the day. I think we did a lot for our first class on algebra. All right, okay. So our next topic, let me see what's going on here. Yes, we're on target. This is our last topic, like terms. So we're gonna see why like terms is important in our next class. But for now, this is a skill set that many people take for granted. And so when they get the hard, complex, long questions, they shambles because they overlook the importance of like terms. And when I say like terms, we learn about different types of algebraic terms, right? What did we look at? We look at the fact that they need to have, we need to look at the different parts of the terms. So I'm going to give you the definition first, and then we're going to look at some examples. All right, so let's just read this out loud so that we have an idea. So if two or more algebraic terms have the same variables, that means it has the same powers. They are called like terms. And I'm going to show you why it's important to pay attention to the powers. So for example, we're going to give you some simple, straightforward, easy examples. So you realize what our focus here is? Our focus is the variables. That's why I put it in black. That's your focus. So once you have the same variables, you are a like term. So an example like that is what? 5a, 3a, 4a. All of them have what in common? All of them have a's as their variable. So all of them are like terms because they all have the same variable. So I have a question for you. But let me give you some more examples first. So I have 3b squared, 7b squared, 8b squared. These are also like terms because what is our variable here? Our variable is b squared. So even though you realize here the variable has a power, but it makes this entire thing a specific variable of b squared. So that is why all of this is like terms. Another example. I want to use different colors so it stands out. I'm going to try this. So let me use black and red. So let me use 8. Just put a comma here, 9. Put a comma here, 2. And I want y'all to see the variables in these examples. So here, our variable is now AB cube, AB cube, AB cube. So another version of like terms. And I'm going to give you one and I'm going to ask what y'all think about this set of examples. Minus 2a, 3a, 1 over 4a. Are these like terms, guys? Is minus 2a, 3a, and a quarter a like terms? Excellent job, my awesome people. Remember, the only thing we're focusing on is what? The variables, once it's an A, don't care what's going on in front. Don't care what the coefficient is. The coefficient could be positive or negative. The coefficient can be a whole number or a fraction. Once the variable is the same, it is the same. It is called like terms. All right. So we're going to do a quick activity to determine. I'm going to do some, I'm going to put some questions and we're going to number, well, I wouldn't say number, but we're going to classify it, whether it is like terms or unlike terms. Okay. So let me know when y'all done. I could scroll out first of all. Let me do that. And I'm going to shift this to the right, so we can see our rules and also look at our examples. So we're gonna copy down this class activity, and we're gonna do it. And then once we're finished, we're done for the day. And we're gonna do just a quick recap. Letters besides A. Oh yeah, you got all kind of letters that could come. That's what we're gonna look at now. So question number 1, we're gonna take it one by one, and then I'm gonna add them. So let's go, be ready. Question number 1, let me use black so we can see it better. So everybody ready to go? We're going together. So as soon as I finish writing it, you are going to type in the chat like terms or unlike terms. Okay? And please copy down these examples in your book. Ready. We're starting off easy, and as we go forward, we get harder. So let me run it. First one. Go. Are these like terms or unlike terms? Let's go. Let's go. Everybody, let's go. That's right. That's what we're talking about. Excellent. Straight to the point. Because in this case, what is our variable, guys? Make sure you be able to identify the variable X. Excellent. We're taking it up a notch now. Number 2. Go. Like terms or unlike terms? You all are very correct. It is unlike, because what is our variable in this first example? X square, but what is our variable here? X, and that's 2 different things, so it's unlike. Very good. Let's go. Keep it moving. Number 3. Remember, as we move along, we're gonna keep getting. We're gonna give you different types of examples. So number 3, I don't know why I have a red pen here. Let's go. Tell me, Mom, what you gonna be? She said, you don't know it. There we go. Excellent. Unlike, because in the first one, our variable is B, next one is C. So the answer is unlike. Very good. So we're gonna move a little faster. Next one. Now I'm gonna increase the number of terms. I'm taking off the music because I want to see something here. This is a challenge. I'll let y'all know. What y'all think? I want everybody to try. I'm watching, I'm waiting for everybody else to make a decision. You have to make a decision. You have to get into the habit, even if you're not 100% sure. It's about always making an effort based on what you think, what you know, what you understand. That's everybody. The answer is like. How I get like? Which one is the one that look like it's throwing it off? Let's be honest. The first term, the second term, or the third term? Which one throwing it off a little bit? Which is the one that make you question it a little bit? The third one, innit? And I want you to remember, what does this mean? What does this mean? A divided by 2. What does that mean? That mean a half for 2. A half for A. You know this mean the same thing? I want to write this over because I want y'all to see this, because people get trapped like this. So I want you to learn this now. This means the same thing as, remember when we learned fractions, right? This means the same thing as this, 12, a half of A. These 2 things mean the same thing. A half of A. What is here doing? A divided by 2. How do you find a half of something? A divided by 2. Hello? Can y'all hear me? My Zoom just mashed me up there. The Zoom just give me attitude and just shut off. What is this? Wait there, guys. Oh, I can hear me? Oh, wow.
I don't see a problem with it.
I never see this in my life before. Like my Zoom gave me attitude. You know, I think before class started, they asked me to update and I tell it no. I told it no, I'm gonna do it after class. I mean, if it vex, well, why? Okay. As soon as class finish, I'm gonna update it. Whoa. I feel like I just got cut tight from my Zoom. Well, why? Okay then. Okay, wait. Nah, that must see. How we get back? All right, okay then. We cooking on gas again. I need to turn off my whole laptop. It probably tired. Yeah, because that's why it just the whole thing just freeze. It kind of do this twitch thing and then just completely shut up. Okay, we're back. My God, it's so embarrassing. Okay, that's all right. So as I was trying to say, my beautiful people, y'all understand that these two things mean the same thing, right? So if somebody said, give me a half of your drink, it means they're really dividing a drink into two. So A over 2 means A divided by 2, which means the same thing as half in your A. So anytime you see P over 2, it means half of 2. That means that, did we change the variable? No, we did not. It is still A. So in this case, that is how we got like terms. So Z, I hope you saw. Bika, I hope you saw and understand why it is like terms. Lord, I must see how much more time we got to class, guys, before my laptop start embarrassing me again. So we got like terms. We got 5 more to go and we're done. So like terms. All right, so let's look at the next one, number 5. Let me see what I have here. Okay, we're getting harder now. Okay, we're going harder now. So I have 10 x squared. I never did an example like this with you. This is solely to test you and see if you are understanding the concepts. So you're gonna look at it and you're gonna tell me, is this like terms or not? What you think? I'm waiting for more people to share what they think. Let's go. You are all right. Very good. Because as you see here, the x squared, y and y. So it's like terms. So even though it's a more complicated variable, it is still the same variable. Excellent job. Excellent. I thought I was going to get catch, but look at y'all. Very good. We're going again. I want to see if this can catch on. You know, watch this now. Let's go. 16my and 12ym. I ain't teach you this neither, but I want to see what you think. Is this the same variable? What y'all think? Suppose I tell her, right? I'm waiting for some more people to share. Stop being afraid. Let's go. Talk to me. Like, you guys, I can't believe it. After all of this, it is like. Very good. Why is it like? Let's look at this part here, the my and the ym. We learn, y'all remember when we were learning the maths. No, don't give up. Don't give up. You're going good. Don't give up. Remember, we learned this in the laws, the maths laws. We learned this in the maths laws. Remember when we learned 1 times 2 is the same thing as 2 times 1? So that means my is the same thing as ym. Very good, Makita. It's the same thing. What rule? Anybody remember this rule? If you remember this rule, what's the name of this rule here? Let me see if anybody remember. Let me mash it up. What is the name of this rule here? It starts with a C. Finish it. That's not the whole name of the rule, Makita. But it starts with a COM. Commutative, very good. You see how the laws is coming, guys? Commutative. Commutative law, which means it doesn't matter what order you multiply or add, it gives you the same answer. So that is why my is the same thing as ym. You remember when I was telling you, see how these rules is come in? They seem very easy, but they come into play when it comes to these type of things. So always try to remember all the minor details. So our answer is like terms. So I'm hoping everybody see that, because ym and my is the same thing, even though they switch the order. So it's like terms. Very good. So I hope those persons who didn't get the right guess, that y'all see why now, so that it could help you remember. Okay, let's go 7. We're taking it up a next notch. 4x squared y 8. Okay, let's go. What y'all think? Look at it. Don't just jump to answering it quickly. Look at it and determine, is this like or unlike? Check it out. Look at the x, compare the two x's, compare the two y's. Is it the same thing? Now, because you see a square, the answer is unlike. Because in this example, how much x's this would be? This is 2 x's, because this is x times x. So this really is x times y, whereas this is x times, what is y squared? Y times y. So here you got 2 x's and 1 y, but here you got 1 y and 2 x. Everybody see that? Hopefully those persons see why it is unlike. We got 3 more to go, guys. We're almost done. 3 more to go. Next one, 8. And I hope you are writing on these examples in your book. You need these examples in your book. All right, so let me turn it up on next now. 19 p squared q. 19. Let's go. Like or unlike? Like or unlike, guys? Talk to me. This one is actually pretty easy. No matter how much letters they throw in there, it's so easy. So for those who share the answer, you all are correct, because here we got completely different variables. This one is the easy. You got P and Q's here, but you got X and Y's here. So totally unlike. All right. Second to last one. We have, I want a hard one, you know. Let me see. I got a hard one for you. -3 x square. Then you have -3. No, something missing from here. Hold on there. That's too easy. Sorry, guys. Sorry. I really want to continue to challenge you, okay? So watching my example, and I realize it's kind of easy. So let's try this then. Like or unlike? Anybody else want to try before we go and look at the answer? The answer is unlike. Very good. Because in this first example, the variable has 2 letters. That's the first thing you have to look at. It only has x squared and y squared, whereas this has 3. Y squared x squared and x. So even though this part is alike, you see this part here, throw it off. So very good job for not getting caught in the web. And the last one for the road is, let's look at it. Again, this example here, so easy. Let me see. Let me see something here. P squared Q R negative 2 R Q P squared. Talk to me. Is it unlike or like? I don't get trapped by this one, okay? Take your time. I'm giving you an extra few seconds to look at it. Anybody else want to try before we look at it? I want everybody to try, please. Let me move it up. What you think? What you think? That's everybody? Okay, let's look at it. The answer is like terms. Very good. Because the truth is, remember, we don't care about the coefficients. All we're focusing is on the R, the Q, and the P square. And even though it's in a different arrangement, it's the same thing. Because look, we got R, 1Q, and a P square and a P square. So it's like terms. How much y'all get on 10? Let me see. Tell me the truth. How much you got on 10? So we got 2 10 on 10s. Don't be afraid. 3. You should let me. I'm waiting for everybody to tell me. You could send me a direct message, please. But I need to see. I need to know. The negatives always throw me off. 8 out of 10, still very good. Make sure the ones that you got wrong, you're correct. You write your correct answer. I think you got 8. Okay. What about Makita? Where you gone? How much you got? All right, so this is where we're gonna end class today. I'm just gonna do a quick recap. We got 2 more minutes, so I'm just gonna do a quick recap just to solidify what we did today and just to give you an idea of what we're gonna be doing next. So next class, now we're going into the real thing. Adding, subtracting, multiplying, and dividing algebraic expressions. That is the beginning, that's level 1. So right now we was on foundation. So on Wednesday, we're going level 1. And that's what we're going to do on Wednesday. All right, so let's just do a quick recap of everything that we did. So remember, it is your responsibility to ensure that you are strong in integers. So that means the rules of integers, adding, subtracting, multiplying, dividing integers. All right, what we did to begin class, we looked at the terminology of known and unknown values. And that was the whole foundation of algebra, where we use letters to represent quantities that are known and unknown. So some cases, for example, I have P number of fingers. I know what P is because I know how much fingers I have. That is 10. So that means P is 10. But then you have cases like the number of stars in a galaxy or how many strands of hair on your head. Who knows that? Who really knows how much strands of hair on your head? Nobody. So that would just be R. So R in this example will be unknown. All right. Then we looked at the simple rules of knowing what a constant is. And we know a constant is the number by itself. The variable is the letter. And in many cases, you can have a single digit variable or double digit variable. And then we have the coefficient. And the coefficient, let me just zoom in here. Sorry about that, guys. I'm talking, and nobody telling me they can't see. But yeah. So the coefficient is the number that falls in front of your variable. So for example, in this example, 3p, you realize 3 is our coefficient. P is our what? Variable. And so we understand these different elements. Then we learn some simple rules. We learn the simple rules where if you multiply a number or a constant by a variable, you just join it. So 2 times a is 2a, or 2a simply means 2 times a, same thing. 4 times m is 4m. So 4m, when you see 4m, you know it means 4 times m. These are very fundamental and important content that you need to remember. When you multiply 2 different variables, you just simply join it. So when you see AB, you know it means that A times B. Then we look at the different parts of any algebraic term. So we had 4 examples. We had 2a minus 3b m squared 2p cubed. You have to look at the 4 parts of that term. You have to look at the sign. Is it positive or negative? You have to look at the coefficient. And we learn when you don't see a direct coefficient, we understand that the coefficient is always what? What is the coefficient when hanging on in front of the letter or the variable? The coefficient is crickets. Somebody. Anybody. What is the coefficient of a variable by itself, guys? So if I write m up here, what is my coefficient of the m? So somebody responded directly, but what about everybody else? So it's 2 things we need to remember about this. This have a coefficient of what? So the person who messaged me directly, you are correct. But what about everybody else? I don't want to have to fight anyone, but let's go. I'm not going to move on until we get some responses. Because what's the point of revising if we don't remember? And the information right here on the board as well. So let me call a name. Janella, are you with me? What is the coefficient of m by itself? It has a coefficient. What is it? What is the coefficient of m? A variable by itself. What is the coefficient? We just wrote down those notes just now. Zimarian, you were late, but you just write down those notes. They ain't give us no coefficient for m, but what is it understood to be? Anybody remember? 1, very good. Whew, thank you for saving me. I nearly dead just now. The same thing applies for the power. What is the power of somebody else? So a variable by itself has a coefficient of 1, even though it wasn't given. But the power, what is the power as well? The power is also 1. Thank you very much. So m by itself has a coefficient of 1 and a power of 1, even when it's not indicated. And the last thing that we look for again is the power. All right, so moving along, we did some translating from worded phrases to algebraic expressions. That was pretty interesting. It took us a while to really solidify and understand the concept or the process, but I hope that we kind of got a hang of it. We were also exposed to expressing consecutive numbers, meaning numbers that come right after each other. Understanding that to move from 1, you either add 1 or you subtract 1, okay? And then we finished off today's lesson by doing like terms. All right, guys, so that's it for today. Before you leave, I need a gauge on how you feel about everything that we did today on 10. Quickly. Out of 10, how you feel about everything that we learned? Today was 8 out of 10, 9 out of 10, 9 out of 10. I have a few notices for you guys. So just give me 1 minute before you leave. Anybody else? 9. All right. So I guess everybody has probably stepped away for a minute. I just want to remind, out of the class of 12 persons, only 3 persons send me work from the multiple choice that was posted on Google Classroom. Now I'm going to tell y'all something. If you wait until it's too late to try to do those questions, it's going to become overwhelming. Do it while your mind is fresh. Y'all realize today we start a whole new topic. Don't wait until you get a bit overwhelmed with this topic and then try to answer them paper one questions. Answer them as soon as possible. You can send me an answer in batches of 25. So if you do 26 to 50, I will send you the answers for 26 to 50. And then you want to send me the other questions after you do so, but please send me something. All right. I'm going to be checking in on y'all, but that's it for today's class. You guys were awesome. And I'm going to see y'all on Wednesday to continue. Have a great night and see you on Wednesday.